Let's write down the Lewis structure of xenon tetroxide. To write down the Lewis structure of any molecule, we need to know the total number of valence electrons. Atomic number of xenon is 54. Therefore, the electronic configuration is krypton, that has 36 electrons, that is the core, and then 4d10, that is semi-core, and then 5s2, 5p6. The 5s2 and 5p6 are the valence electrons. Therefore, we have 8 valence electrons in xenon. Atomic number of oxygen is 8. Therefore, the electronic configuration is helium, that is the 1s2 core, and then 2s2, 2p4. We have 6 valence electrons in oxygen, but we have 4 oxygen atoms. So therefore 24, this is 8 times 1, 8, which means in total we have 32 valence electrons. Using 32 valence electrons, let us write down the Lewis structure of xenon tetroxide. We have to put xenon at the center because that is less electronegative compared to oxygen. And then let's make one bond pair with each oxygen atom. In total we have 32 valence electrons. If we have made 4 bonds, that means we have utilized 8 valence electrons. So therefore we still have 24 valence electrons remaining. That we can put it as 3 lone pairs each around each oxygen. If we do that, then each atom satisfies the octet configuration because we have 8 electrons around each atom, isn't it? Around oxygen we have 3 lone pairs and 1 bond pair, that is 8. And then around xenon we have 4 bond pairs. Therefore that also satisfies the octet configuration. You might think that this is the best Lewis structure, but let us check the formal charges. Formal charge is equal to number of valence electrons in the atom minus number of lone pairs of electrons in the molecule minus number of bond pairs of electrons by 2. So therefore for xenon this is equal to 8 minus we have no lone pairs, so therefore 0 minus we have 4 bonds, therefore 8 by 2, which means 8 minus 4, that is plus 4. We are having a plus 4 formal charge for xenon for this structure. How about oxygen? For oxygen it would be 6 minus 6 because we have 3 lone pairs, isn't it? That means 6 electrons minus 1 bond, therefore 2 by 2, therefore minus 1. So for each oxygen we are having minus 1 formal charge. Although the net charge is 0 here, this is not the best Lewis structure because in the best Lewis structure the formal charges has to be close to 0, which means let's bring 1 lone pair each to the bond pair. Therefore if we make a double bond with each oxygen atom, then we can get the formal charge as 0 for each atom. Now if we calculate the formal charge for xenon, it would be equal to 8 minus we have no lone pairs once again minus we have 8 bonds, so therefore 16 by 2, therefore that is equal to 0. And for oxygen it would be 6 minus 4 because now we have only 2 lone pairs around each oxygen, isn't it? So therefore 4 minus we have 2 bonds, therefore 4 by 2, which means 2 minus 2, and that is also 0. So therefore for each oxygen atom we are getting the formal charge as 0, and for xenon also we are getting the formal charge as 0. So therefore this is the best Lewis structure for xenon tetroxide. Now you might wonder, how come xenon has 16 valence electrons around it, isn't it? We have 16 valence electrons around xenon in this structure. How it is possible? It is possible because xenon belongs to period 5. It has access to empty 5d orbitals. So therefore expanded octet configuration is possible for xenon, and that's why we are having 16 valence electrons around xenon. In the previous structure that we wrote, we had only 8 valence electrons around xenon, and now we have 16 valence electrons around xenon. This just means that it belongs to expanded octet category. Now let us briefly discuss the hybridization of xenon in xenon tetroxide. This is the best Lewis structure that we wrote. But what about the hybridization? For that, let us determine the steric number. Steric number is sum of sigma bonds plus sum of lone pairs. We have 4 sigma bonds around xenon and no lone pairs. So therefore the steric number is 4. If the steric number is 4, then the hybridization has to be sp3. So therefore the actual molecular geometry is tetrahedral. When we wrote the Lewis structure, we wrote like a square planar structure, but the actual molecular geometry is indeed tetrahedral because the hybridization is sp3, which means both the electronic geometry as well as the molecular geometry is tetrahedral, and we have no lone pairs around xenon. That means the bond angle is 109.5 degree.